The quest to understand the universe and its workings is a timeless endeavor. From ancient philosophers gazing at the stars to modern physicists probing the atom, humanity has always sought to unravel the mysteries of the cosmos. In this pursuit, we find ourselves at a fascinating crossroads, where the ancient wisdom of Aristotle, a giant of observation and logic, intersects with the burgeoning power of artificial intelligence, or AI. Aristotle, a towering intellect of ancient Greece, laid the groundwork for scientific inquiry with his meticulous observations of the natural world. His ideas, particularly his treatise on physics, shaped Western thought for centuries, influencing everything from astronomy to medicine. Fast forward to today, and we find ourselves in the midst of an AI revolution, where machines are capable of processing information and making predictions with astonishing speed and accuracy. This juxtaposition of ancient philosophy and cutting-edge technology might seem paradoxical, but it highlights a fundamental truth about scientific progress. It's a continuous dialogue between the past and the present. Aristotle's legacy lies not just in his specific theories, many of which have been superseded, but in his methodical approach to understanding the world, an approach that continues to resonate in the age of AI. As we delve into the fascinating world of physics, comparing and contrasting Aristotle's methods with the capabilities of AI, we'll uncover not only the evolution of scientific thought, but also the enduring power of human curiosity. To truly appreciate the impact of AI on our understanding of physics, we must first journey back to ancient Greece and step into the world as perceived by Aristotle. Central to Aristotle's physics was the concept of natural motion. He believed that every object in the universe had a predetermined place, and its movement was a striving to reach that natural resting place. For example, a rock being made of earth naturally sought to return to the ground, while fire, being lighter, yearned to ascend towards the heavens. This concept of natural motion extended to the celestial bodies as well. Aristotle envisioned a geocentric universe with the Earth at its center and the sun, moon, and stars embedded in concentric crystalline spheres that revolved around our planet. Each celestial body, in his view, was engaged in a perfect, eternal, circular motion, reflecting the divine order of the cosmos. To explain motion that didn't fit the natural category, Aristotle introduced the concept of forced or violent motion. This type of motion, he argued, was imposed on objects by external forces and ceased as soon as the force was withdrawn. For instance, a stone thrown through the air was undergoing forced motion. Once the thrower's impetus was exhausted, the stone would return to its natural state of rest on the ground. Underpinning Aristotle's entire model was the idea of a prime mover, an unmoved and eternal entity that set the universe in motion and kept it running. This prime mover, while not directly intervening in worldly affairs, provided the initial impetus for all celestial and earthly movement. Aristotle's physics, rooted in observation and logic, held sway for centuries, influencing generations of scholars and shaping the intellectual landscape of Western civilization. However, despite its intellectual dominance, Aristotle's model was not without its flaws. As scientific inquiry progressed, particularly during the Renaissance and the scientific revolution, cracks began to appear in the seemingly unshakable edifice of Aristotelian physics. One of the most significant limitations of Aristotle's model was its lack of mathematical rigor. While he made astute observations about the natural world, he did not develop a corresponding mathematical framework to quantify his observations or make precise predictions. This lack of a quantitative approach limited the predictive power of his physics. Further challenging Aristotle's ideas were concepts like inertia, which remained elusive in his framework. Inertia, the tendency of an object to resist changes in its state of motion, was formalized much later by Galileo Galilei and Isaac Newton. Aristotle's physics, lacking the concept of inertia, struggled to explain why an arrow continued to fly through the air even after leaving the bowstring. Furthermore, Aristotle's geocentric model of the universe, while aesthetically pleasing, was eventually overturned by the heliocentric model championed by Copernicus, Galileo, and Kepler. The shift from an Earth-centered to a sun-centered cosmos marked a profound change in our understanding of our place in the universe. Despite these limitations, it's crucial to remember that Aristotle's physics was a product of its time. His observations, though lacking the technological advancements available today, were meticulous and laid the groundwork for future scientific inquiry. His emphasis on observation, logic, and a systematic approach to understanding the natural world continues to hold value even as our scientific understanding evolves. Fast forward to the present day, and we find ourselves amidst a technological revolution spearheaded by artificial intelligence. This revolution is not merely changing the way we live and work, it's also transforming the very fabric of scientific exploration, particularly in the realm of physics. AI, with its uncanny ability to sift through massive data sets, discern patterns and make predictions, is providing us with a new lens through which to view the universe and its intricate workings. At the heart of AI's transformative power lies its prowess in data analysis. Modern physics experiments, from the Large Hadron Collider to astronomical observatories, generate an overwhelming deluge of data. Human researchers, limited by the constraints of time and cognitive capacity, often struggle to process and analyze such vast amounts of information effectively. This is where AI steps in, acting as a tireless and incredibly efficient data analyst. AI algorithms can sift through petabytes of data in the blink of an eye, identifying subtle correlations and patterns that might escape even the most astute human observer. This ability to process and analyze vast data sets is particularly valuable in fields like astrophysics and cosmology. AI is being used to map the distribution of dark matter, analyze gravitational waves from colliding black holes, and even search for signals from extraterrestrial intelligence. In each of these areas, AI is not merely assisting human scientists, it's pushing the boundaries of what we thought possible. AI is also proving to be a powerful tool in the search for new physics beyond the Standard Model, the current best framework we have for understanding the fundamental building blocks of the universe. By analyzing the results of particle collisions at energies never before achieved, AI algorithms can help physicists identify discrepancies that might hint at the existence of new particles or forces, potentially revolutionizing our understanding of the cosmos. For centuries, the debate between Aristotle's natural order and the data-driven approach of AI has shaped our understanding of the universe. Aristotle's influence laid the groundwork for centuries of philosophical and scientific inquiry, emphasizing a world governed by observable natural laws. However, as we venture into the depths of the 21st century, artificial intelligence stands as a testament to human ingenuity, offering unprecedented capabilities for analyzing and interpreting the cosmos. Today, we find ourselves at a unique intersection of history and technology. While Aristotle's vision provided the foundational principles of natural science, AI propels us into new dimensions of discovery, making sense of data at scales and speeds unimaginable in Aristotle's time. As we move forward, let us embrace the wisdom of the past, while harnessing the power of modern technology to unlock new frontiers in physics. Thank you for watching AI versus Aristotle, a timeless debate on physics. Please like, share, and subscribe for more insightful content. Together, we continue to explore the universe, guided by the legacy of ancient thinkers and the promise of cutting-edge innovation.